Hello everybody, this is a second example for the asset pricing model that we developed together, and that will be a nice application in terms of reinforcing the things that we learned. And we take the argument one step further. We were in the two states of the future states of the world case. Now we still keep the two-period model, except that now instead of two future states of the world, we have three possible states of the world. So because we have three possible future states of the world, we need at least three securities for which we know the current price, which we have right here. So LG is a hypothetical fictional company. LG's company has stocks outstanding, currently trading at $48.34. It also has bonds outstanding, trading at $970.28 today. This is the current price. And there's also call options outstanding related to the LG stocks. And the strike price for that is $50, and those call options are being traded at $5.12. Now, so for these three securities, we know the future contingent payoffs for these three securities, and they are as follows. So in the case of LG stocks, which is currently priced at $48.34, if state 1 were to materialize in the future, then the stocks will be selling at $74. If state 2 materialize, that stock will be worth $55. And if state 3 were to materialize, that stock will only be worth $39 and will lose significant value compared to its current value of $48. So we do the same thing for LG bonds and call options. We know exactly, well, actually it's interesting. For LG bonds, because it's a bond contract, regardless of the state, the future state, it always gives a $1,000 payoff where the current price is $970. So once you invest in that bond, you pay $970, and a year later you are guaranteed to receive $1,000 regardless of the state of the world, regardless of that future state of the world. There is, I just left the case of call options blank here, the future states, and we can easily do it together because the strike price is $50, and because the call option gives its purchaser the right, not the obligation, to purchase the stock at $50 a year later. So if in year 1, a year later, state 1 materialize and the underlying stock is trading at $74, then we want to exercise our right to purchase the stock at $50. Why is that? Because as soon as we pay $50 to buy the stock, then we are gonna sell it right back to the market. Now remember, the call option, you receive that call option from another party, right? You are buying the calls from that party that you signed the contract with. So that's pretty good. And as soon as you buy those stocks at $50, you dump it to the market at $74, and you make a $24 profit right away. Does that make sense? So if state 2 were to happen a year later, stock price would have been 55. Again, you would use the same strategy and buy it at 50 and then sell it at 55. You make a $5 profit right away. Only in the case of state 3, because a year later the stock will be trading at $39. Why would you exercise your right to buy the stock for $50 while it is from that party that you signed the call option with, rather than buying it from the market? So you would definitely buy it from the market. So therefore the call option will go without being exercised. That's it. So given these payoffs, so these are given, let me write that down. Given these three future payoffs in those three future states and the current prices of the stocks, these are the current prices for which of these securities, I should say, then the question is, go ahead and find these. So basically, we want to value these securities, asset K and asset Q, using the no arbitrage principle. And we learned that the way to do it is using state contingent claims. So the price of a state 1 contingent claim, let's assume it's P1. The price of a state 2 contingent claim is P2, and the price of a state 3 contingent claim is P3. So what that means is the following. Let me remind you what it means. State 1 contingent claim is a claim for which you pay P1 today. You pay this amount today, and in return, it pays you $1. If state 1 were to occur in the future, which is uncertain, we don't know which of the futures, either state 1, state 2, or state 3 will happen in the future. We don't know which of the three, but what we know for sure is if I purchase state 1 contingent claims, I paid P1 today, and in return that's the state contingent claim, state 1 contingent claim will pay me $1 in state 1 and nothing in other states. State 2 contingent claim, I purchase it by paying P2 today, and in return, a year later, if state 2 happened, that will pay me $1. It's like a lottery ticket in that sense, right? It only pays you if that state of the world happened. And P3 is the price of the state 3 contingent claim today. If state 3 happened in the future, it will pay you $1 in that future state 3, but nothing in if state 1 or state 2 occurred. So because we want to replicate each of these three given securities, the stock, the bond, and the call option. So what we need to do is we need to use appropriate combinations of state 1 contingent claims, state 2 contingent claims, state 3 contingent claims, such that it will replicate this future scenario. So this is the first scenario, right? So how can I replicate it? Easy. So I can replicate this by buying 74 state 1 contingent claims, 55 state 2 contingent claims, and 39 state 3 contingent claims. Each of these is priced at P1, P2, and P3 respectively. And because I replicated that stock perfectly, it should be equal, its value should be equal to the $48.34 the stock price value, right? So basically the first equation will look like this. $48.34 is equal to 74 state 1 contingent claims, 55 state 2 contingent claims for each one you paid P2, and 39 state 3 contingent claims. So this is a portfolio of state contingent claims, portfolio of state contingent claims, and state contingent claims 1, 2, 3. Let's see if this replicates our stock. So if state 1 were to happen, how much payoff will this portfolio give to its owner? Well, if state 1 happened, because I own 74 state 1 contingent claims, it will pay me off. Each one will pay me $1. So 74 of them will pay me $74. Wow, look at that. Exactly the same amount that the stock pays. You guys see that? So in that regard, the portfolio and the stock, they have the same payoff if state 1 happened. But the same thing is true for state 2. If state 2 happened, the stock will pay $55 and the state contingent claim will also pay $55. And finally, if state 3 happened, the stock will pay $39. And look at the state contingent claim. Each of them will pay $1 if state 3 happens. And because I own 39 of them, I will get $39. Wow, so that's it. So that portfolio, that's portfolio consisting of state contingent claims, is an exact copy of the stock. We artificially created a stock. Now what we can do is we can go ahead and do the same thing for the bond. And now I'm just writing the equations right away. I'm not gonna bother explaining it. 1000 P1 plus 1000 P2 plus 1000 P3, and the last one is the call option, $5.12 equal 24 P1 plus 5 P2 plus 0 P3. Whew. Now you have a system of 3 equations, 3 unknowns. Just solve it. Now you might say, wait a second, This is significantly harder than the 2 by 2 case, two equations, two unknowns. You might have said, wait a second, why did we use Excel? Why do we use matrix inversion? I mean, it seems like redundant, but now you see the whole thing. It would be very difficult to solve this system of equations. Even though you learned how to solve system of equations sometimes in middle school, like 7th grade or so, it's extremely difficult. You know that it is challenging. What if there was 4 equations and 4 unknowns, or 100 equations and 100 unknowns, like in the real world? Then suddenly things are totally different, right? So you know that you need to use some computational tool, right? So once we calculate the value of P1 and P2 using arguably Excel, I guess, then we will go back and answer the question of the value of our asset K and asset Q, right? We can find an exact value for asset K and asset Q by using the same principle. We will reconstruct asset K and asset Q using state contingent claims, and then based on that we can calculate the price of those two securities. The current price for asset K, let me write it like this, just to make sure everyone understands this is today's price of asset K, will be basically a combination of state contingent claims in the following sense: 175 P1 plus 0 P2, I can skip that, plus 120 P3. That's it. So if I can solve this system of equations, 3 equations and 3 unknowns, solve it for P1 and P2 and P3, I can just plug them into this equation and I can calculate the value of stock asset K. Similarly, the value of asset Q today, actually, you know what? Let me just write, it's easier, so because it's confusing when I write it like this. Let's just write it K sub 0 and Q sub 0. How about Q sub 0? Well, Q sub 0, it pays $30 if state 1 happens, so I need to purchase 30 state 1 contingent claims. I need to purchase 30 state 2 contingent claims, and finally I need to purchase 50 state 3 contingent claims, and this way I would replicate the asset Q basically. So I'm so close. All I need is to solve this system of equations, but solving a system of equations is exactly linear algebra, right? So let's just go ahead and look into the Excel right away. Okay, I just copy pasted what we have so far into Excel. And now let's have Excel do its magic. So we have a matrix of coefficients, or let's call it coefficient matrix of that system of equations, coefficient matrix, which happens to be all just the coefficients of that 3 equations and 3 unknowns. So 74, 55 and 39. The coefficients of the second row are 1000, 1000 and 1000, and finally the coefficients of the last row are 24, 5 and 0 basically. That's it. So what we will do is next is the inverse of that matrix, of coefficient matrix. Well, that's easy. So it will be a 3 by 3 matrix, and all I do is go to formulas, math. We did it many times. If you by now memorized it, just start typing it into Excel, right? I'm using, where is it? I'm using this one, matrix inverse. And very easy. All I do is describe which matrix I want to take the inverse, this one, and press OK. There you go. This is a matrix of inverses. Now finally, the prices, state contingent, before the state contingent prices, let me write down the vector of values. On the other side of the equation, we have 48.34, 970.28, and 5.12. All right, now finally, the prices, state contingent prices. Well, we will have P1, P1, the price of the state 1 contingent claims today, P2, and P3. So that's the goal, to calculate those three prices. Well, I know that each one will have a different price. It will look like a 3x1 matrix, which will come out by simply multiplying that 3x3 inverse coefficient matrix with that 3x1 vector of coefficients, vector of values, 3x3, 3x1, just drop off the middle three, the 2 3s in the middle, so 3x1 again. So this will give me that. So all I need is either you can go back to the formulas, math, and then matrix multiplication, m multiplication, this function, or you can directly start typing in the cell. Either way works. All right. So matrix multiplication. What are the two matrices you are trying to multiply? The first one is this one, and the second one is the vector of values. Make sure this order is correct, because matrix multiplication, as we said earlier, is not commutative. All right, that's it. These are the prices of the three state contingent claims: the P1, the state 1 contingent claim, the state 2 and state 3 contingent claims. Now that I know these state contingent claims, now I can calculate the value of any asset, any value of assets. Remember, this was the whole thing is asset pricing, right? So we can calculate the prices, the values of assets. So let's start with K0, I guess. Maybe I can capitalize this. All right. So K0 means the price of asset K today. Given that asset K promises these amounts in the future. And similarly, what is the price, the value of asset Q today? How much can I pay for it, given that it promises me these future payoffs? All right, so for K, it will be very easy. It's equal to 175 times P1, this monster, plus 120 times P3, not P2, P3, and press enter. There you go. So for a security which promises $175 in state 1, nothing in state 2, and $120 in state 3, well, I think it's a fair price would be $82.39. To pay this much is fair for that security. Because in 2 of the 3 states, it will end up making you a profit. Only if state 2 were to happen, and this is the part which is kind of reminds us of a lottery or gambling. That's the part which is very risky, right? Anyhow, but Q0, by the same reasoning, so we can easily calculate the value of Q0 as well. It's 30 state 1 contingencies, so 30 times the price of each state 1 contingencies is this much, 30 state 2 contingencies, times each one is this much, plus 50 state 3 contingencies, 50 times this amount. Make sure you understand the logic and press enter, and this is the price for asset Q. Do you guys see how easy things are once you know the state contingent prices? So this is the critical step in the solution. In a sense, we constructed an algorithm. Everything is smooth as long as you follow the steps of the algorithm. It seems if 1, 2, 3, 4, 5 steps, but some of these steps is almost redundant, like this one, for instance. It's just writing down the values of the assets. That's it. But yeah, so it's very safe. For instance, if I were to create yet another asset, so say for instance, if there's another asset P, for instance, well, the asset P promises, say, I don't know, $25 in state 1, nothing in state, or $15 in state 2, and nothing in state 3. I can easily even value that asset, right? So the value of asset P, at time 0, how much should I pay for it? Well, very easy. So you should pay equal to 25 times. You need to first of all purchase 25 state 1 contingent claims, each one priced at this amount, plus 15 state 2 contingent claims times 15, and each one is costing you this much, plus 0 units of state 3 contingent, or you can just skip that last one. And that's it. Just press enter. And that one, the fair price is $8.74. Yeah, so you should pay at most $8.74 for oh sorry, this one. I was thinking it should be a bit more. Yeah, so for this security, yeah, it's worth that much, I guess, right? So that's what the theory tells us. How much, if you're wondering how much to pay for that security. Do you guys realize that the method that we developed is very powerful? So matrix algebra is amazingly powerful. So in the next example, I will finally give you an example with four future states of the world. So 2 periods, 4 future states of the world. And then lastly, we will look at what if it's not 2 periods, what if it's 3 periods, t equals 0, t equals 1, t equals 2, multiple uncertainties across time. How do you handle those situations? And that's it. So we are very close to the state of the art. What companies, especially trading companies, use this type of software to try to value security, see if there's any arbitrage opportunities and things of that nature. All right, so let me stop the recording for this one.